So in the previous class, we have discussed about the basic introduction about microprocessors and microcontrollers. And now we'll go in depth about the microprocessors and microcontrollers, and we'll start with the difference between microprocessors and microcontrollers. Now let us compare both the devices. A microprocessor contains only the CPU, whereas a microcontroller contains the CPU, memory, and peripherals on a single chip. The microprocessors require external RAM, ROM, and I/O devices, whereas microcontrollers have these components integrated internally. Microprocessors provides high computational performance and are mainly used in computers. Microcontrollers consumes less power and are used in embedded systems such as washing machines, microwave ovens, and automobiles. So these are the basic difference between microprocessors and microcontrollers. Next, we will see the architecture comparison. The architecture diagram highlights the integration level. In a microprocessor based system, memory and peripherals are connected externally. In microcontroller based system, all the major functional blocks are available within the same chip. This reduces hardware complexity, power consumption, and overall system cost. If you see the applications of microprocessor, microprocessors are used in desktop computers, laptops, accounting systems, gaming machines, industrial controllers, traffic control systems, and other applications that require high computational performances. And let us see the applications of microcontroller. Microcontrollers are widely used in mobile phones, automobiles, washing machines, microwave ovens, digital cameras, security systems, watches, and many other smart electronic gadgets. They are preferred whenever a dedicated control function is required. Next, we will see an example of an inductive heating system and microwave oven, which is a microcontroller. Uh, this is the final slide that shows the two practical applications of a microcontroller. An inductive heating system uses electromagnetic induction to generate heat efficiently for industrial and domestic applications. Here you can see the inductive heating system, and here you can see the microwave oven. First, we will see the inductive heating system. So, as previously said, it is using a electromagnetic induction to generate the heat that is for industrial applications. So we can see the different blocks that are available in an inductive heating systems. Starting with an input signal generator, that is function generator, we have AC DC converter and power switch and a rectifier, and it is connected to the transistors, diodes, and isolator half wave bridge rectifier, and to a heating system, and it is connected to microcontroller. Microcontroller is connected to memory, EEPROM, EEPROM, and display, and it is further connected to the external devices for IO operations. And input devices are sensors, and the output device is our application. So based on this, it generates the heat based on the electromagnetic induction in the coil. So this is one of the example of a microcontroller. Next, we will see the microwave oven. So this is the basic block diagram of a microwave oven. Here also we can see different elements such as signal generator, door switch, thermostat, relay, and we have different relays, and we have cooling fan, we have boosting circuits, we have magnetron, and we have display control MCU, and we have display LED, and we have input and output peripherals, and we have main control MCU. So this microwave oven uses a microcontroller to control cooking time and power level, keypad input, display, sensors, and safety mechanisms. Based on the selected settings, the microcontroller controls the magnetron to heat the food efficiently and safely. So we can see the magnetron. So this magnetron is the primary element. The microcontroller controls this magnetron to heat the food efficiently and safely. So this is another one example of an microcontroller application. So far we have seen two examples. One is inductive heating system and another one is microwave oven. To conclude, so we have learned that microprocessors and microcontrollers are both programmable electronic devices, but they are designed for different purposes. A microprocessor is mainly used for general purpose computing and requires external memory and peripherals, making it suitable for computers' high performance applications. In contrast, a microcontroller integrates the CPU, memory, and the IO peripherals on a single chip, making it ideal for embedded systems and a dedicated control applications. So understanding the architecture, features, advantages and applications of these devices help us choose the appropriate technology for different electronic and computing system. We also studied the basic architecture of microprocessor and functions of ILU, registers, control unit and different processor architectures such as RISC and CISC, important performance parameters like instruction set, bus, clock speed, IPC, bandwidth and word length. In addition, we have learned about the types of microcontrollers and their advantages and disadvantages and compared with them microprocessors. So, as future electronics and communication engineers, understanding these two devices is very important because they form the foundation of modern digital systems, embedded systems, automation, robotics, consumer electronics, automotive electronics, and Internet of Things applications. So, let us conclude today's session with this basic info. In the upcoming classes, we will explore these concepts in greater depth by studying their internal architecture, instruction execution, interfacing techniques, and real world applications. I hope now you have a clear idea about what is microprocessor and what is microcontroller and their applications, mainly in the modern systems like modern digital systems, embedded systems, automation, robotics, consumer electronics, automotive electronics, and Internet of Things applications. So, thank you for your attention. We'll meet you in next lecture.